Okay, this is a video to help you with your homework. We've got this curve. It's given by y squared equals x squared times the quantity x plus 7. In our picture, they graph it for us. We're shown this. That's what this curve looks like. And in part C, you were asked to revolve this around x equals negative 7. So we're revolving it around this line. And let's see what happens. In order to do that, the first thing we do is sketch the region, and we also sketch the reflection. So I'm going to draw this over again, down here with just a little bit more space. So I'm going to say that that's x equals negative 7, and then for symmetry this should be x equals negative 14. And what we're going to see is this loop. I'm not doing a very good job drawing it. It's not supposed to cross x equals negative 7, but we've got that. And then when we graph the reflection, always want to graph the original region. And then sketch the reflection. So it would appear that I'm going to see the same loop over here, just a mirror image of that. So I'm going to try to draw the same loop, probably unsuccessfully. That's okay. Yeah, it's not a very good mirror image, but you get the idea. It's supposed to be that one just mirrored over here, and that's difficult to do. So the mirror image is this part in blue, and it's creating a very strangely shaped solid of revolution. Now, because we are in the cylindrical shell section, and we're going to slice the original region parallel to the axis. And the axis was given to us. It was that x equals negative 7. So when I slice parallel to the axis, it would be better if there was a little bit more symmetry in my picture. I'm going to see a slice like this. Since my axis was vertical, my slice is going to be vertical. And then when that gets reflected, I'm going to see the same image over here. Maybe if I did a better job with my graph, it would look better. But you're going to see the same image over here, and that rectangle, when it gets revolved, is going to form a cylindrical shell. So we slice the region parallel to the axis to form a representative rectangle. Then we revolve the rectangle about the axis. To form a representative cylindrical shell. And now we're just going to find the volume of this shell. So we know if we take a cylindrical shell that looks like this, we slice it down the side like a can of beans and unfold it, this dimension here, that width of the shell is equal to the width of that rectangle. So if that's delta x, that's delta x. The height of the shell is that distance there, and that's going to be the height here. I'm just going to use h sub I. Looks like a high. And this is h sub I. It's delta x. And then this dimension here that distance all the way around, that's just the circumference of that circle where the radius is there. So we're going to have 2 pi r over here. Okay, so that should be enough to get us our volume. So we're going to state the equation for the volume of the cylinder. Volume is going to be circumference, which is 2 pi r, times the radius times the height, times the width or the thickness of that shell. So I just need the radius and the height as functions of x because of that delta x over there. Okay, so now I look at my picture. I notice that my height is a vertical distance. So the height is going to be the top y value minus the bottom y value. And both of those are going to be as functions of x. Now on this curve, y squared is equal to x squared times the quantity x plus 7. So if I want to get y by itself, I have to take the square root of both sides. But don't forget the plus or minus. So y is the positive square root of this, which is the top half, part of the time, and then y is the negative square root of that, which is the bottom half. So our top half is positive square root of x squared plus 7, x squared times the quantity x plus 7. And we'll put a little I there because we're evaluating it at the ith x value. And we're going to subtract the y in the bottom. So we're subtracting a negative. So that gives us that right there. Subtracting a negative is the same as adding, so it looks like we've got 2 of these. I see where a sign error could come from this. Now, the square root of x squared, you might be tempted to think that's x, and that is true whenever x is positive. But if x is a negative number, and x is negative this whole time in this region, the square root of x squared is going to be a positive number. If x is negative, we're going to take it and we're going to multiply it by -1 to make it positive. I know that seems a little strange. That's just to say that the square root of x squared is the absolute value of x. And if you're not sure, you can check it out. Just if you plug in 2, square root of 2, or 2 squared is 4, take the square root of 4 and you get 2. So if this is my x, the square root of x squared is x when x is positive. Now if I plug in -2 for x, you square that first, you get 4. Square root of 4 is positive 2. So the x was negative and the answer was positive. So either way the answer is going to be positive. So what this is giving us is the absolute value of x. And the absolute value of x is x when x is positive or when x is 0. And it's opposite of x when x is negative. Remember your absolute value graph looks like this. It's that V shape. The function's equal to y equals x over here, but when x is a negative number, say it's -2, when we take its absolute value, it gets flipped up here. So this is the line y equals -x. Because we're taking all those negatives and multiplying them by -1 to make them positive. And then over here, this is the line y equals x. So that's why we see this. So with that in mind, this square root of x squared here isn't x. Because, look at our domain, x is negative between -7 and 0. So the square root of x squared can be replaced by negative x. That is a little tricky. And the square root of x plus 7 can't be simplified. So we've got this right here. Now you might be saying to yourself that that's a negative height, but it's not, because it's an x value is negative, a negative times a negative is positive, and that's a positive number. So all of these together are going to make a positive. Okay, so that's our height. And then the radius is x on the right minus x on the left, which is just x minus -7. So we get x plus 7. So that's going to go right here. My radius is x plus 7. My height is -2x times the square root of x sub I plus 7. And all of that needs to be simplified. Ooh, it's got a lot going on there. All right. So my total volume is equal to the limit as the number of shells goes to infinity of the sum as I goes from 1 to n of 2 pi times the radius, which is x sub I plus 7, times the height, which is -2x sub I, times the square root of x sub I plus 7, times delta x, and that's going to give us this right here. 2 pi times -2 is going to be -4 pi. And then you've got an x times an x plus 7. You could distribute that. That's going to be x times x is x squared. X times positive 7 is 7x. And I've still got the square root of x plus 7 over here. Dx. And look at your original region. You can either look at it here, or you can look at it before we reflected it. X goes from -7 to 0, from smallest to largest. Okay. Now this is looks a little tricky. You could use integration by parts to evaluate this, but I think this is easier to evaluate using a U substitution. So I'm going to do a fancy U substitution. It's called fancy because basically well, you'll see. You'll see why it's fancy in just a second. So we're going to let u equal the expression under the square root. So u is going to be x plus 7. Now du is just 1 dx. And you might think to yourself, well, if I have a 1 dx, well, that can be taken care of, and the square root of x plus 7 can be taken care of. But I don't know what to do about this x squared plus 7x over here. Well, we can actually simplify this quite a bit. Or maybe I shouldn't have simplified this up here. I think I've changed my mind. Notice you've got an x plus 7 to the first, and here's an x plus 7, and we're taking the square root of it. Remember, whenever you have the square root of a, that is a to the 1/2 power. It's a to this power over this power. So this is actually x plus 7 to the 1/2. So just going to scratch that for right now. This is equal to that, but it's not helping us, so I'm going to write it differently. I'm going to keep my bounds, keep the -4 pi. That x, I'm just going to factor out. So now I've taken care of the 2 pi and the -2x, but now I've got this x plus 7 and the x plus 7 to the 1/2 power. Now, because of exponent properties, I've got something to a power times a different, or times something of the same base to a different power. So that's just like x to the n times x to the m. If the bases are the same, you add the exponents, that's n plus m. Yeah, this is going to be much more efficient than what I was thinking I had to do over there. So we've got -4 pi times x. This is x plus 7 to the 1 plus 1/2 is 3/2 dx. Okay, now we're going to do our fancy u sub. So x plus 7, that's my u. And the derivative of x plus 7 is just 1, so du and dx are the same thing. And you might think to yourself, well, if that's true, there's no way I can take care of this x. And that's generally true, but I can actually get x in terms of u using this equation. If I know that u is equal to x plus 7, then I also know that x is equal to u minus 7. I can solve this equation for x. Okay, so this is going to be a u minus 7. So I've got that in terms of u, that in terms of u, that in terms of u. The only thing I need now are bounds in terms of u. So my equation for u is x plus 7. So I'm going to substitute the upper bound here, 0, in for x, and I get my upper bound for u is 7. These are x values because it's an integral in terms of x. We're integrating with respect to x. These have to be u values because we're integrating in terms of u. Now when I substitute in negative 7 for x over here, negative 7 plus 7 is 0. So that's my new bound for u. So u goes from 0 to 7 when x goes from negative 7 to u. So then we still have the negative 4 pi. The x is u minus 7. This is u raised to the 3/2 power. And that part is just a du. That I can work with. I've got u to some power there. I can distribute it. So we wrote our integral entirely in terms of u. That's right here. Add those exponents. We're just using that property again. U to the first times u to the 3/2 is u to the 5/2. And we're subtracting 7 times u to the 3/2. Then bring the negative 4 pi down. Then you want to add 1 to the exponent and divide by the new exponent. Bring the negative 7 down. Add 1 to the exponent and divide by the new exponent. Plug in 0 and 7 and subtract. When we substitute in u equals 0, we get 0. So that's our answer. It's just not simplified. Now, if I want to simplify all of these as much as possible, one way that we can do that is we can write these 7 to the 7/2 and 7 to the 5/2 as 7 raised to a whole number plus a 7 to a 1/2 power. So basically I'm just using this rule but backwards. I want that to be a perfect whole number right there. I want it to be an integer. So I can make that 7 to the 6/2. 6/2 is 7 cubed, times a 7 to the 1/2, which is the square root of 7. That is not a cube root. That's saying take 7 cubed and then multiply it by the square root of 7. Then over here we've got a 14 over 5. And that 5/2 can be split into 4/2 times 1/2, or 4/2 times 7 to the 1/2, like this, because if we add those exponents, we get this back. And 7 to the 4/2 is just 7 squared. That's square root of 7. And so I end up with a 49 times square root of 7 over here. Okay, so this 7 goes into this one once, so we're going to have a 49 there as well. So we've got negative 4 pi times 2 times 49 times square root of 7. And over here we've got negative 14 over 5 times 49 times square root of 7. If you want, you could factor out the 49 times the square root of 7. That's 49 times 4. I think that's 196. So I've got negative 196 pi times the square root of 7. I factored out the 49 and the square root of 7, so there's still a 2 left. And over here, that's a 14 over 5. Two is the same as 10 over 5. If you were worried about that negative, because you said to yourself, volumes can't be negative, that is a valid concern, but it turns out that 10 over 5 minus the 14 over 5 is going to give us a negative 4 over 5, and things are going to simplify quite nicely. So we get 196 times negative 4, and I don't know why I started writing square root of 2. That should be a square root of 7, guys. I'm so sorry. 196 times 4 is 784. So I've got 784 times pi times square root of 7, all divided by 5. All right, that's our answer. Now, as I go through the method and I look at the solution that you wrote online, Tim, I think the only issue is that minus sign. I think you have the right answer, but because you said the square root of x squared was x, not negative x, and it is negative x when x is negative, unfortunately, you have the right answer times negative 1. I don't think you simplified it. I think what you have is this right there, but without the negative in front of the 4 pi. So that's encouraging. That means you did it right.